So the next ones we're going to do, I'm going to keep referencing this of what am I finding, what do I have, how do I solve it. So I'm going to look at example 19. So what do I have? I have a right triangle. What am I finding? I'm finding a missing side. So I'm not going to solve this with inverse. It'll either be the Pythagorean theorem or it'll be trigonometry where we cross multiply. Because we don't have two sides that we know the length of, we have an angle on a side, this is going to be solved with trigonometry. So I'm going to put it in the same color as our trigonometry problems above. So my right angle is here, which makes my hypotenuse the 20. The acute angle is here, and across the triangle is the x. So it's opposite. I don't care about the adjacent leg, so katoa, we're going to be writing a sine ratio. So I'm going to say sine of my angle is 42, is equal to the ratio of opposite over hypotenuse, x over 20. So when you do this, let me go back to it. When we're using trigonometry to find a side, we solve it by cross multiplying. So I'm going to put that left side over 1 so it looks like a proportion, and I can multiply. X times 1 is x, and it will be found by 20 times the sine of 42. So 20 sine of 42, if you put it in correctly, you should be seeing 13.4 if you have rounded right, because there's a 13.38, the 8 makes the 3 round up. So then let's look at number 20 right next to it. So I notice another right triangle. So everything's fair game. And I need to pay attention to the fact that the hypotenuse is the side I'm looking for. I'm not looking for an angle. I'm not about to do inverse. I'm also not about to do the Pythagorean theorem because I don't know two of my sides. I know an acute angle though. And right next to that acute angle is the adjacent leg of 10. So katoa, I'm going to write a cosine ratio. Cosine of my angle is equal to the adjacent leg over the hypotenuse. So again, when you are finding a side length, you solve it with, when you do a trigonometric equation, you solve it by cross multiplying. That's what I'm going to do here. I'm going to put it over 1. 10 times 1 is 10. It's going to equal x times the cosine of 29, which is not something I can put in my calculator. I need to know x by itself. I need to do the opposite of this multiplication. And the opposite of multiplying by the cosine of 29 is to divide by the cosine of 29. So what I'm putting in my calculator is 10 divided by the cosine of 29. So some of us get to just type that in. For the rest of us, we'll kind of walk through that one because that one is a pain. So just to make sure we're clear. 10 divided by, then I need to tell them what angle I'm using. I want regular cosine of 29 and go ahead and say what does it equal once I've divided by. So both calculators are telling me about 11.4 for this answer. So I've got my two sides here. I'm going to skip number 21. I'm going to do 22 because when I want to immediately point out about 22, x is not a side. X is an angle. We said when you're finding an angle in a right triangle, we're still going to use trigonometry, but it'll get solved differently. We're going to use inverse. So I'm going to start the same though. I'm going to say, hey look, right angle, making that my hypotenuse. Then I need to pay attention to the acute angle. There's a question mark there, I put an X. And the 44 is on the other side of the triangle. It's opposite. So I'm going to say so katoa, that's an H and an O, that's a so. So I always put sine of my angle, and then I set it equal to the ratio of opposite over hypotenuse. This is when you do inverse. This is when I would, back when I first taught you this lesson, say we will take sine inverse to both sides of the equal sign. And the reason we do that is inverse is the opposite of regular. So in our calculator, we need to figure out what is sine inverse of the fraction 44 out of 58. So you need the second sign, not regular sign, sign with a little -1. And again, for those of you with the unfortunately programmed calculators, we would type in first the 44 out of 58 and figure out what decimal that is, and then say I want sine inverse. So not regular sign, sign with a -1. So both calculators tell me when I do sine inverse of 44 out of 58, I'm getting about 49 degrees. So that angle is about 49. And then apparently I decided just to skip down. Sorry, I got distracted. Down to number 25. So number 25, still a right triangle, but you'll notice x is a side length, but I don't know a single angle. You cannot do trigonometry without an angle. Whether you're finding that angle or you're given that angle, it's essential to have an angle for trigonometry. If instead you just have two sides, you're going to do the Pythagorean theorem. So don't forget the Pythagorean theorem still exists. Not everything will be trigonometry. So still care where your right angle is. Across from the right angle is still your hypotenuse. But then don't label anything else because the legs don't matter. The Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So I'm going to put in that square root 65 to be squared. A and b will be the x and the 4, and the order of those don't matter. Ooh, that was weird. So let's square numbers. Let's start with the easy ones. 4 squared is 16. Now, there's a couple ways you could do this, and if it had been a smaller number than 65, I'd show you a couple ways. But the key thing I want to point out is we said when you solve that solving by square roots, squaring is the opposite of square rooting. So they cancel each other out. I just have a regular 65. You could go ahead and multiply them out if you want. It's not super necessary, especially since there's no coefficient. So now my goal is to get x by itself. I'm going to start by moving the plus 16, which means I'm going to subtract 16. I get 49. I want to get rid of the squared, so just like I did here, where squaring is the opposite of square rooting, I'm doing that here too. So x is equal to technically positive and negative 7, because 49 is a perfect square. But since I'm finding a side length, I'm just going to go ahead and say I got 7. So there are a couple other examples I could have run through, but honestly, these are the 4 main key things to take away. So finding side length, sometimes we cross multiply with trig. Finding side length, sometimes we do Pythagorean theorem. But if you're doing trig, pay attention to whether or not you should be multiplying or you should be dividing. And the only way to tell that is when you cross multiply, what does your equation look like? If you're finding an angle, your only option is to do inverse, sine inverse, tangent inverse, cosine inverse, but you got to find an angle using inverse. So honestly, I really think whether you use this summary or one that you've written down on your own notes, doesn't really matter, but I think it's really helpful to kind of see these are the main things